we go?
I guess we can get going.
Okay.
It's 2 minutes after. I suspect a few more people will be filing in quietly.
Yeah.
They're probably going to sit around those chairs. So, okay. So,
Yeah, there's an introduction.
Yeah. You don't get to start
I don't get to start
before I
this
speak.
Okay.
So it is my great pleasure and honor to be presiding this jury. We are going to hear Anna Offenwanger telling us about sketch-based support for expressive personal visualization. On the jury, we have a lot of people attending remotely. We have Professor Sheila Carpendale from Simon Fraser University, Canada, Professor Daniel Keefe from University of Minnesota, USA. We have Professor Samuel Huron, who is nearby, but actually remote, from Telecom Paris. Dr. Petra Eisenberg is sitting here with us in the room, and myself, Emmanuel Pietriga, who is also at INRIA, like Petra. And we have also the two advisors, Fanny Standilas here in the room, and Fanny Chevalier in Washington right now, in the state of Washington, in Seattle, Washington, but from University of Toronto. Okay, so Anna, you have 45 minutes, and then we follow up with questions and answers.
Awesome. Okay, so let me just get my thing reset here. So thank you everybody for being here today. I'm going to be presenting my thesis work, Sketch-Based Support for Expressive Personal Visualization. This work was conducted under the supervision of Theophane Standilas and Fanny Chevalier. Special thanks to the jury for being here to hear this work. Okay, so diving right in. Visualization. Visualization is the process of taking abstract data and visually representing it. Visualization is most frequently used for data analysis, and in this context, it needs to be impartial, rigorous, and efficient. However, visualization is also starting to be used in personal context for things like self-reflection, for sense-making, for communication, as an extension of that for storytelling. In this context, the goals are different. People value visualizations which are expressive and personal. Expressive personal visualizations are idiosyncratic, meaning unique to the individual. This is an example from a research project done by Georgia Lupi and Stephanie Posavec called Dear Data. In this project, the two designers would collect data for each week in the year. They would then create a visualization of this data by hand drawing it on a postcard and mailing it to each other. You can see that the visualizations they created this way are very unique. They have these unusual hierarchical structures, and each visualization is very different from each other, so unique to the individual designer who drew it. In contrast, many visualization tools offer a very limited range of both structures as well as ability to personalize. You can customize, so this is an example from spreadsheet software. It gives you a fixed set of visualizations to choose from and only has limited customization. So generally speaking, expressive personal visualizations are hard to create because of a lack of tool support. In this thesis, I am aiming to develop tools to support expressive personal visualization. To give a brief outline of what I'm going to be covering in the next 45 minutes, I'm going to start with my framing. So what attributes of expressive personal visualization I am aiming to support specifically. I will then quickly go over previous work, what tools already exist to support these attributes and what they are not supporting. I will then discuss two tools which I have developed to support expressive personal visualization, time spines and data garden, and wrap up with a reflection on how supporting personal attributes of visualization can also support storytelling. So, rolling into my framing. In order to concretely define what it is I'm trying to support, namely expressive personal visualization, I collected a set of examples of existing visualizations and then analyzed them to extract the following attributes as making a visualization personal. These are personal visual style, subjective emphasis, and inclusion of context. I'm going to show you a couple of my examples to illustrate what I mean by these attributes. So personal visual style is something that we've just seen. It is that kind of individual and unique flair that somebody gives to a visualization they create. This is particularly noticeable in visualizations created with manual tools, such as physical pens and papers, but can also be done with digital drawing tools. But you can also notice this in visualizations created with more digital tools. The second attribute, subjective emphasis, is the individual spin that somebody gives to a data set. This is a visualization created by the researcher Charles Perrin, where he collected 2 years worth of time information, so how he was spending his time on work versus personal activities. Just to quickly explain the visualization, this green side here, the stream graph represents time spent on work activities, and the purple side is time spent on personal activities. In this visualization, Charles Perrin used annotations to highlight portions of the data that might be seen as significant. For example, vacations and how that's causing a lot more personal activities. Yeah, so annotations are one way of highlighting things that are significant or important within the data, emphasizing them. The third attribute is what I call inclusive context. This is how the visualization author connects the data to the surrounding events or context of how that data was collected. This can again be done through annotation. For example, there's notes here saying like the events that were happening at that time, but it can also be done through the structure of the visualization. Perrin's visualization here, he very specifically chose this spiral pattern to emphasize the cyclical nature of the research year. You can notice that specifically in this little section here, where you have this giant increase in amount of time spent on work running up to a March deadline that many people here will be familiar with. So to summarize, what I'm looking to support are these attributes of personal visual style, subjective emphasis, and inclusion of context. And these can be supported through how the visuals are drawn, through the use of annotation, and through the structure of the visualization. These are important points which I'll be referencing in the tools that I design. So that rolls us into tool support. So another important point to consider when designing tools is what tools have already been designed, what they are good for, and where they fall short. When I am talking about tools, I am not just talking about digital systems. Sketching is something that we very frequently see when designers are creating these custom unique visualizations. Bigelow, Drucker, and Fisher and Meyer observed that designers initially sketch visual representations on paper, whiteboard, or an Illustrator. This is an example of one such design process. This is a visualization done by Nadia Bremer as part of the Data Sketches work. And she shared kind of some of her initial sketches that she came up with when creating this visualization before going on to the D3 programming language to create the final representation. Sketching has a number of advantages. First off, it is quick and direct. You can just, jot down what it is you're thinking of. It is ultimately flexible. You can draw anything that you can imagine, basically. It also supports multiple levels of fidelity, from just quick sketches to get an idea, to mid-level where you're actually drawing in real data points, to full-fledged visualizations like we see for Loopy and Posavec. However, there are some limitations to sketching. The first one of these is what we call mapping. Stephanie Posavec in the Dear Data project ran into this in the week 2, where she observed that distance between the points is arbitrary. I tried to make the distance of the lines based on numbers, but it proved to be impossible by hand. Just for folks who are less familiar with visualization, mapping is the process of linking visual attributes to underlying data values. Like, for example, trying to make this length of a line represent some kind of number. This is extremely difficult to do by hand and make it accurate. So doing this through sketching can be very inaccurate and quite tedious as well. This is one of the challenges that we're looking to address. Another challenge is the process of iteration. Sketching is interestingly both good and bad for iteration. When we're dealing with these, quick throwaway sketches, it can be great because you can draw an idea, throw it away, get another idea down. But when we get to the process of actually including data, it becomes quite difficult. When you're dealing with these extremely custom and unusual shapes, it can be difficult to imagine what the final layout is going to look like. And creating the visualization by hand is extremely slow, so you can't really try out different versions. This is an example of the different variations that Perrin went through when he was creating this visualization. So automated tools can step in to support you in this area. Tools like the spreadsheet software that I showed before are really good for mapping. We can take data and tell it just lay out the points. It'll do it extremely quickly and extremely accurately. But as we've already mentioned, it lacks that kind of personalization that we're looking for in these expressive personal visualizations. There are more complex tools that offer more flexibility. So for example, the D3 programming environment, a lot of visualization designers will often go to these tools because they offer that ability to come up with these custom shapes. But of course, they have two very obvious limitations. The first one is you need to know how to program. That means most people cannot use these tools. Secondly, even if you do know how to program, they're not really well suited to getting this kind of personal style that you can get when using manual tools almost automatically. Previous research has stepped in to try and address this gap. This is the Data Inc. project done by Chiarish, Chevalier, Arduino, and Wigdor. This particular application is using the lazy data binding technique, where you start by drawing your visual elements. They're using pen-based input to allow people to create custom glyphs, and then they give access to different visual channels, for example, color, to link those glyphs to data. This particular application is really great because through sketching, it's very accessible to many people. It's very flexible. You can get all kinds of different glyphs, and it really incorporates that kind of personal style. However, it is limited in the kinds of structures that you can create. You can link data to the color of the glyphs as well as to the positioning of the glyphs. For example, you can arrange them in custom shapes, but there's only one hierarchical level that you can get in that arrangement. This means that we cannot achieve visualizations like we see in the Dear data, where you have like a primary axis and then sub-axes, and then where the glyphs on that axis are positioned mean something. Additionally, you cannot arrange things along an axis. So for example, this visualization that Karen did, where data is positioned along the axis is related to time. This is something else that previous research doesn't support very well. So to summarize what I am trying to achieve, I would like to support expressive personal visualization by combining the advantages of sketching, its quickness, its directness, its ability to support personal visual style with the power of automated tools, this ability to do quick mapping and iteration, as well as extending support for the structures that are currently available. Namely, I'd like to support hierarchical visualizations as well as continuous mapping. So with that, that covers the background work, and we are now going to roll into the applications that I created to support these expressive personal visualizations. Starting with the first project, time splines, sketch-based authoring of flexible and idiosyncratic timelines. This work was conducted with my co-authors, Matthew Brammer, Fanny Chevalier, and Theovanis Tenzilis. It was published at Viz in 23 and won a Best Paper Award, which was very gratifying. So, timelines are an important visual element for storytelling with data. Timelines come in many shapes, and the standard linear timeline doesn't really cover people's varied and personal conceptualizations of time. Previous research has explored the uses of these unusual timelines. For example, as we've already seen with Perrin, the shape of a spiral can emphasize the repetitive nature in time. Custom timelines have also been explored for their ability to improve memory. This is an example from Mark Twain from 1914, where he was encouraging custom timelines to help people remember history dates. So in this work, we are interested in what we call idiosyncratic timelines. This is similar to Bremer et al.'s classification of arbitrary timelines, but the term arbitrary doesn't really capture this idea that the custom shape has meaning that's individual to the author. So for example, another one of Mark Twain's visualizations where turns in the line indicate a change in a period in history. When dealing with storytelling and time, we also have to deal with the fact that time is not always linear. This is a visualization of the movie Memento, which has this really weird passage of time where the movie mostly goes forwards and then about 1/3 of the way through turns around and starts moving backwards in time. Even when we're not dealing with weird storytelling techniques like this, even normal films will often use time manipulations such as ellipses to skip over boring bits in the timeline, or time dilation to emphasize significant moments. This is something else we need to consider with personal conceptualizations of time. So We aim to support idiosyncratic timeline, and therefore there were some challenges that we needed to address based on everything that we have discussed, including the considerations for expressive personal visualization. We identified the following design considerations. We need to be able to support flexible representations and manipulation of time. We need to be able to support multimodal annotation, and we need to be able to support heterogeneous and cumulative temporal data. In order to do this, we created the time splines application. I am now going to briefly give you a brief overview of how the time spline systems work, and then dig more deeply into how we supported each of these design considerations. So, time splines has two main views: the canvas on the left here, where you're able to directly manipulate visuals, and then the data drawer on the right. This is where you can load in your data and then connect it to the line. The tools that you can use to do this are in the middle. I'm going to run through a quick fictional scenario showing an example of a person using the system. In this scenario, the author has just reached a significant milestone in her hobby of long distance running and wants to reflect on her journey. So, the author has noted down a number of significant events and collected statistical data on her running. She starts by loading these into the system and visualizes them on a straight timeline. She immediately notices this large gap and adds some annotations to explain what's happening. At first, she thinks she'll de-emphasize it with an ellipses, but then she changes her mind and decides to represent it as a loop instead, to signify ending up right back where she started. She adds some annotation to explain what was happening at the time, as well as some sketched annotation to kind of capture the feel of this period. And with that, her visual representation, or her temporal representation, is complete. So she adds the rest of her data, as well as some custom media, and then finishes up by styling the graph. Hooray. So, to dig down a little bit deeper into all the different features that we've seen here, in order to support a flexible representation of time, we not only need to support manipulating the shape of the line, but also the temporal flow. Time spline supports time manipulation in a variety of ways, including the ability to cut, merge, and move lines around. As you make modifications to the temporal representation, the system does its best to keep existing data consistent with the changing representation. This includes moving data items as well as warping drawn annotations. So to control the flow of time, time splines introduces the concept of time pins. Pins fix dates to certain points on the line and can be moved to change the passage of time or removed to return time to a constant passage. In order to support, thank you. In order to support multimodal annotation, as we have already seen, time splines adds the ability to add textual annotation as well as drawn annotations. We do this to be able to support the wide variety of annotation that we see in existing idiosyncratic timelines. In addition to being able to add these annotations, the annotations are also linked to the temporal representation. This starts to blur the line between what we consider to be data and what we consider to be annotation. This line is further blurred through the support for heterogeneous and cumulative data. In time splines, we adopt the lazy data binding technique, where visual elements are first and foremost visual, and the data binding is applied on the fly as needed. To illustrate, additional data can be added to the line at any point during the authoring process. The binding is two ways, so when users update values in the table, it updates them on the canvas and vice versa. Users can also add additional text items to the table from the canvas. This workflow promotes promotes these annotations from annotation to data and starts to blur the line between what we consider what. There we go. In order to evaluate how time spline supports expressivity, we took a three-pronged approach where we conducted a reproduction study where we got 12 novice participants to try recreating a visualization. We then conducted a freeform study where we asked researchers and designers to create a visualization with a data set of their choice. And then we created a gallery of visualizations ourselves to show the potential of the system. In the reproduction study, we asked the participants to recreate the visualization on the left. We did not require them to stick exactly to this representation, and we can see through the sketch-based interface how the system really supports this idea of personal visual style. We also see a variety of different annotations from the hand-drawn annotations as well as some text. For the freeform study, we gave 4 participants 3 hours to create a visualization on their own time with a data set of their choice. We saw that these participants utilized both metaphorical as well as figurative elements in the visualization, demonstrating both the inclusion of context as well as subjective emphasis. I'd like to discuss P13's visualization in particular. P13 did a spatio-temporal map of a mountain bike ride where the passage of time follows the route that was taken on the ride. Some of the interesting features in this visualization are the use of loops to indicate where time was passing, but they weren't moving, as well as figurative annotations like these sweat droplets to indicate how difficult it was to get up certain parts of the hills. In the gallery, among other things, we demonstrated the pragmatic use of idiosyncratic timelines. This is a visualization I created of 400 years of my family history. I used the custom shape of the line to integrate the additional media and make them more streamlined with the graph. This is a visualization created by my co-author, Matthew Bremer. He's visualizing statistical data from his music listening on this curve. He very specifically chose this outward curve of the shape to enable him to have enough space to include these images along with his statistical data. Integrating image and statistical data can actually be quite tricky, which brings us to some of the limitations of the system. First off, along with the uses of idiosyncratic timeline, we also encountered this problem. As P13 puts it, it's not possible to have both very interesting curves and the data being super readable everywhere. P13 and Matthew ran into this problem and took different approaches to solving it. P13 did this through subjective emphasis, aligning the axis of their graph so that the peak points in the data, the elevation where they're at the highest, stands out the farthest, thereby emphasizing those victory moments in the ride. Matthew did it through the use of a particular style. He very specifically chose only very shallow curves so that the data would still be readable. This can be viewed as either a personal visual style or possibly a limitation. It'd be nice if we could have a custom shape of any, have any kind of shape while the data is still readable. Previous research has looked into solutions for these problems. This is the transmogrification technique, and it would be interesting to see how techniques like this could be integrated into a system like timesplines. As a final note that I would like to jump back to, as I mentioned before, timesplines takes this approach of blurring the line between annotation and data. Annotations like this text are added to the data tables, really promoting them to the status of data. Annotations like this, the hand-drawn annotations, however, are not added to the data table. However, they still contain information, and it'd be interesting to know how we can take these hand-drawn annotations and extract that data from them. So this brings us to our second system. So the data garden system, so data garden formalizing personal sketches into structured visualization templates, was again conducted in collaboration with my supervisors, Fanny and Fanis, and was published at the Viz conference in 2024. So the data garden project was kind of built around this core question of how can we structure sketches as data? Of course, keeping in mind everything that we've discussed with respect to expressive personal visualization. The first challenge that we encounter when we start to ask this question of how do we structure sketches is the wide variety of structures that people express with their sketches. Trying to build a system that can cover all of them is intractable, so we narrowed down on a specific class of visualization. I went through the Dear Data project and I identified this class of visualization that I call plant-like visualizations. They're characterized by having a primary axis, then sub-branches coming off of those axes, and leaves on the sub-branches. Those leaves can then also have sub-icons on them, creating these unique hierarchical visualizations. Because of the hierarchical nature of the visualization, they have a tendency to look like plants, which is why I call them plant-like visualizations. We chose this particular class because they are well supported by pen-based interaction, but not well supported in existing systems. So as in timesplines, we wanted to utilize a lazy data binding workflow to explicate, I want to go over the lazy data binding workflow to explain what I am talking about here, as we ran into a limitation with this workflow, which required us to extend it. So lazy data binding, so as you saw in time splines, you start by creating visual elements, and then you can bring in data when it makes sense to do so, and link the two together to create the data mapping. The system can then use this mapping to update the visualization, and then you can iterate back and forth between the visual elements and the mapping to create the final visualization. The limitation we ran into with this workflow is that it assumes that you already have the data set in existence. What we wanted to do with Data Garden was slightly different. We wanted to start with drawing the visualization, then explain to the system what these visual elements mean in order to then extract data. This is much closer to what would be called an input visualization workflow. Input visualizations have previously been studied by Huron and Willett. They did a survey of existing input visualization systems, and one of the things you might notice about these is a lot of them use manual or physical input. This is probably due to the flexibility that these visualization or that these input techniques offer. So what we're looking at here is much closer to an input visualization workflow, but we realized we could actually take it one step farther. By formally specifying this data mapping, we can then reverse the flow to use the sketch as a template, add data, and then generate a final visualization. This is what we call a sketch-based templating workflow. So in order to demonstrate the potential of this sketch-based templating workflow, we created the system Data Garden. So I'm going to run through a quick example of how Data Garden, or what it looks like to structure a sketch within Data Garden. In this particular example, I'm creating an activity data visualization where each branch is going to be a week, each stick on the branch is going to be a day, and each leaf is going to be an activity. So as I start sketching my visualization, the system attempts to infer what I intend with regards to my hierarchy. It uses a fairly naive algorithm to achieve this, which works quite well in simple cases, as you can see here. Once we've drawn the visualization, we then need to specify what the data mapping is, what I mean by the data. For this, we have the Data Dimensions tab. This tab enables us to add dimensions and specify how the strokes represent data. I start here by choosing the middle level of my hierarchy, the sub-branches, and binding each to a different day. I then switch to binding my color dimension. As soon as I specify color, the system is able to infer that I've got two different colors here and sort my strokes accordingly. I can then specify what each color means and also what this dimension represents. In this case, whether or not the activity is a fun or work activity. Data Garden also supports binding continuous visual channels and dimension. Here I'm choosing the position channel, and the system infers what value is meant or by the distance that each leaf is along the branch. I can then specify what the extent of the numeric range is, and the system can then use the position to infer what numeric value is currently represented by the leaf. Once I have all my dimensions, I can switch over to the table tab, and the system will show me what it has inferred from the sketch in terms of the data. So Data Garden demonstrates a system that supports the sketch-based templating workflow. In order to achieve this, there were some technical challenges and interaction challenges that we needed to address. So first, we need to be able to support the ability to structure sketches. To keep the sketch or the workflow sketch-like, we implemented some simple heuristics to infer the author's intended hierarchy. The heuristic worked well in the last video where the structure was fairly simple, but as it gets more complex or ambiguous, it can be more difficult to infer. Here, it's difficult to know what parts of the gnome are meant to be a single glyph versus which parts are meant to be a child of the main branch. We implemented a simple interaction where we can just select strokes in the overview tab and tell the system directly what's meant to be a single glyph, as well as correcting the hierarchical representation. To support the data mapping, we needed good mechanisms to help understand what the machine is understanding and interpreting. We used color highlighting to help link the abstract representation to the actual visual glyphs. So here you see it highlighting. I'm trying to figure out where it's interpreting the positions of each node. We also added mechanisms that allow us to specify or through direct manipulation what the values are meant to be. So here I intended there to be 3 different energy levels and 3 different shapes of gnome. I can directly specify how many levels there are and then place the gnomes in the correct category. Finally, in order to be able to demonstrate how these templates can be used as templates, we needed to show how they could generate a full visualization. It wasn't our goal when implementing Data Garden to create a robust solution for the generation problem, but we did want to demonstrate how the templates can generate final visualizations. So again, we implemented a naive algorithm, which works quite well in fairly simple cases like this, or for example, this, which we pulled from the Dear Data catalog. It even works in more complex examples like this visualization that I did for my own mood data, but does definitely have some limitations, which we will loop back to. Again, we wanted to evaluate how expressive the system was, so we took the same approach where we conducted a reproduction study, a freeform study with researchers and designers, and created a gallery of visualizations ourselves. So in the reproduction study, again, we see how this sketch-based interaction workflow really supports these personal visual styles, as we can see when we look at the differences between P1 and P4's results. We also see how some participants really caught on to this idea of templating. P9 only included the absolute minimum number of glyphs that they needed to specify what the visualization template was supposed to be. P10, on the other hand, preferred to draw out the full visualization. In the freeform study, we asked participants to create a visualization for a data set that they just came up with on the fly. We also asked them to try out the template that they created with a data set that we created for them based on the structure that the system inferred from their template. So we can see the original visualizations that they sketched up here, as well as the generated visualizations from the system. Generally, participants really like the workflow. E1 described it as the more fun way to specify a visualization. It also helped them think through their data sets. They mentioned things like having to think through the possible data values, as well as considering what the extreme results might look like. We saw participants using a variety of different glyphs from more concrete glyphs like these books representing different reading, as well as more abstract shapes like these concentric circles representing travel. So you'll notice that there are some distinct visual problems in some of the generation, and this is something that we reflected on. Data Garden is mainly designed to support explicit data mapping. So that's telling the system what each stroke represents. When an author is doing this, it's very obvious that they need to do this because the only way for the system to know what strokes represent is to tell it. However, when you're drawing a visualization, there's also all these implicit constraints that you might not necessarily think of. As a human being, I don't need to tell you that these branches are meant to alternate sides of the branch. Or when you add extra branches, the main branch needs to go bigger to accommodate them. Or leaves should probably be shaped so that they don't overlap. Data Garden has no way right now to specify these implicit data mappings. And it's kind of difficult to know how we're going to, how to achieve this. So like, how do we recognize these implicit aesthetic intents without forcing the author to specify them manually every single time? And how can we build tools to help support it when the system doesn't recognize it automatically? These are challenges, or these are open challenges that are still to be addressed. Okay. Seems I'm doing pretty good on time. So those are the 2 systems that I wanted to present. I am now going to wrap up with a reflection on the expressive personal visualizations that have been created from these systems during my work. Specifically, I want to reflect on how supporting personal attributes of visualization supports storytelling and how story structures can inform tool design. So storytelling is one of our oldest forms of communication. In previous literature, it has been defined as accounts of what happened to particular people and what it was like for them to experience what happened in particular circumstances and with particular consequences. I observe that visualizations are accounts of what happened, including context can give you particular circumstances and particular people, and subjective emphasis can give you what it was like for them to experience what happened. So I would argue that including these attributes of expressive personal visualization can automatically turn a visualization into a story. I would like, therefore, to analyze some of the expressive personal visualizations that have been created from the systems that I have generated from this angle. Specifically, I'd like to use existing story structures as a lens to reflect on the systems I've built. And I'd like to focus on two structures specifically, framing structures and kernel storytelling. So the framing story structure is the story within a story. These stories can appear in a single relationship with an outer and an inner story. For example, the Princess Bride movie is an example of this. Or they can occur in sequence. So you'll have one overarching framing story and little, sub-stories jumping out of that. The Arabian Nights is probably the most common example in Western literature. If we look at the visualizations from time splines from this lens, we can see how some of the features supports this kind of storytelling. So this is a visualization of some of my own data. I like to track my work activities. So this is showing all of my activities from Mondays in January of 2022. The stream graph shows how productive those activities are. As I demonstrated when we were talking about timelines, you can cut and move these subsections, thereby changing the overall framing of the visualization. This is kind of analogous to changing the overall framing story, and the ability to manipulate the little subsections is like being able to manipulate the sub-stories. Another visualization that's interesting from this perspective is this visualization, again created by Matthew Bremer. This is a visualization of the events in the fictional biography of Forrest Gump. This visualization is particularly interesting in this context because the movie Forrest Gump is actually another example of a framing story. Interestingly, Matthew actually added an additional sub-story that isn't in the original movie by breaking out the events that happened before the movie into their own little sub-graph. This actually highlights a limitation with the time spline system. Matthew connected this particular graph to the main graph with these hand-drawn annotations, but time splines doesn't actually support the ability to link lines. When we look at framing stories, we'll often see common themes or characters appearing multiple times in the sub-story, creating these links between the subsections. We can see an analogous behavior within some of the data visualizations we see in Dear Data, where connections are created between data events, creating a more holistic visualization. Right now, time splines doesn't enable you to create links between the individual sublines, and adding this feature could be a way to improve time splines' ability to support storytelling. Okay, so the second structure I would like to discuss is called kernel storytelling. Many of the visualizations we see in both time splines and Data Garden are kind of hard to see as stories. Take this visualization from the Data Garden gallery. This is a visualization of my personal mood data. Each root section is a day. Each flower on that section is a mood entry that I have put in. The flowers represent the rating of the mood from 1 to 5. And the emotions that are associated with that entry are represented on each leaf as these little beads. Now, there isn't really a story here until I point out these specific little red beads here. This represents the emotion tense. So when I enter in my mood data, I give it a rating and I tell it which emotions I have. This emotion tense appears on pretty much every single flower in this set. When I get tense, my mood tends to fluctuate wildly, which is why I selected this week, because it gave me a very good a very good sampling of all the different mood ratings. So as I'm telling it here, there's clearly a story here, but the story isn't there until I'm standing here telling you about it. Kernel storytelling is a brief reference to the subject, central action, or an important piece of dialogue from a longer story. A kernel may develop to a different length depending on the conversational context in which it is told. Because these expressive personal visualizations aren't always directly readable, they can serve as story kernels. So you'll notice in many of these visualizations, they don't directly include the legend or how to read it within the visualization itself. This is another example from the designer Georgia Lupi. She created this visualization of medical data to help a friend in coping with the illness of one of their children. The visualization itself doesn't include the legend. If you want to be able to read this visualization, you have to go read the explanation on the website, which is included in the context of the overall narrative of what was happening and why they were creating this visualization in the first place. This non-readability enables authors to choose where and in what context they share what about the visualization, giving them greater control over what they share with whom. Additionally, because these kind of visualizations aren't immediately readable, it requires viewers to take more time and attention in order to understand what's going on. Visualization research often focuses on making visualizations faster and more efficient for information communication. But if we conceptualize expressive personal visualizations as story kernels, this forces us as designers to consider the context in which these visualizations are going to be made and shared, and more holistically, the tools that are going to be used to do this, making the process more user-centered. So with that, I will roll into my conclusion. Wow, I'm doing really well on time. I don't think I've gotten through it this fast. So I'm going to quickly discuss some directions for future research here. As I mentioned at the beginning, I wanted to support additional structures for expressive personal visualizations. I have demonstrated how to use sketch-based interactions to support timelines and hierarchical structures, but I also want to point out that the systems that I've created are also limited to these structures. There's still a great deal more work to be done in covering even the range of visualization structures that we see in the Dear Data examples. I've also mentioned additional features like linking that could be incorporated directly into these systems that I've created. So there's a lot more directions of design that these systems can be taken in. In addition, there's also the question of how we can support people in creating visualizations in styles that they don't necessarily have the skills to produce. For example, watercolor styles or vector graphic styles. In the final summer of my degree, I had the opportunity to do an internship at Microsoft where I was working with generative AI. The work from this internship has been incorporated into a paper, which is being published at CHI and also received an honorable mention, which is also very gratifying. What we were working with was how we can specify intent within these generation systems. It'd be interesting to know if we can use these generative AI tools to help people specify personal visual styles. But there's this question of whether or not it's even possible to make something personal with an AI system. It's saying, I would like my visualization to be in a watercolor style enough to make that a personal style, or will the system send you something back and you go, well, I didn't make that, it's not personal. So this question about whether or not intent is enough to make something a personal visualization is an open question that remains to be explored. A final direction I am currently taking my work in is transitioning from 2D to 3D environments. I'm working with another student at the University of Toronto on a system for doing personal immersive storytelling. The system that we're creating is specifically designed to be used in context of migration, but also has applications to immersive data visualization. We're incorporating concepts like this idea of personal emphasis, as well as this concept of inclusion of context via linking within this application. So I'm hoping that I might be able to take it in a little bit more of a personal data direction. Yeah, so we'll see which direction this goes. I didn't have time to talk about this during the presentation, but more than happy to discuss it more if anybody has questions. And with that, I would like to thank you for your time and attention, and we can roll over into the question phase.
Thank you. So as usual, we'll start with the rapporteur, who are Sheila Carpendale and Daniel Keefe, and tradition dictates that we start with the jury member that is farthest from us. But at this point, between, I was going to say between Seattle and Vancouver, but it's actually between Minnesota and the state of Washington. So Sheila, please, if you can start the Q&A session.
Okay. Well, yes, thank you very much for your talk. That was, nicely summarized. So yes, where do I start with questions?
I'm glad they picked you first.
Yeah, exactly. Okay. I mean, I guess the first thing that I want to ask is, so you have your list of let's see, I just thought I brought it up so that I would have it handy, but of course I can't find it. Yes, you have your list of what's different between, the different types. And you did start at the beginning talking about templates and sketching and coding as the three predominant ways that we make visualizations, right? And you spent most of the time talking to us about the expressiveness, the access of, like, is it expressive or is it not expressive, right? And but there are other factors. So if we, yeah, and I mean, that's a whole other direction of questioning. Like, you pointed out over and over again in the thesis and through this talk that it's sort of helping with expression. Like, it is more expressive than what we've had before. But how satisfied do you feel about, where it's going? And would you continue on this same direction? What would be, the next way, the next place that you would go if you were still focusing on expression?
Right. So if I'm understanding the question correctly, you're kind of getting at how these systems, they're more expressive, but there's also still some limitations in terms of expressivity. And you're wondering how I might push further in exploring that kind of divide.
Yeah, just what would you choose as be the next direction for increasing expressivity?
So interestingly enough, I would probably look down this channel of AI, because what is kind of really hard to get a grasp of is, like, what does this expressivity even mean? I know it, like, for myself personally, what I'm looking for is this sense that I have really managed to get from what it was that I was trying to express to something out there that actually represents it. And very frequently I run into this problem where I'm trying to do something and it's just not working, and I want to be able to just try more things faster, or things that I might not even necessarily be able to create. And I think there's some potential within the generative systems to do this. Just like from my experience with using them, it's really quick to get something which, I react to emotionally. I go, hey, that's cool. But then I try to go further with them, and it's like I just can't get the control of them that I want. So I'd really like to know, like, how can we make these generative systems that have a lot of power more controllable? Like, how do I use them for expression in ways that I cannot do right now? So that's probably the direction I would take it in. Do you want to follow up on that?
Well, yeah, maybe, because you even actually brought up, so I have a few friends, artist friends, who have thought, I mean, I have artist friends who are just like, about AI, and got all kinds of rhetoric about that. But I have some saying, hey, I'm going to use this, like, kind of like you know. I have yet to have one who is, okay. So the ones who are satisfied don't mind if the AI system does something, like, they don't, the word that you used is control. Some people don't mind that it has no control and that it does things that whatever, right? And some people really mind. And so that's a big question about, like, is AI controllable for expression? And do you think that's a question that your direction is going in? Would you think that would be so you would think that would be interesting to try and explore?
What I want to understand is where it's like, I'd like to really be able to pin down this line of what is it that causes somebody to go from this is just doing random stuff and I can't get it to do what I want, to I am able to make something expressive here. Like, where is that line of personal expression? How do we define what makes something expressive, where it's actually creating something that I'm trying to capture? Like, how it's kind of hard to describe, which is why I would like to study this, because I would like good words to describe this. And that's kind of like one of those things I want to pin down. It's like, what does expressivity mean in these contexts? So like, what does it mean to express something in a generative system?
Yeah, well, okay. I'll just give you an example of the way I think about this. I'm not sure that it's the direction. Anyway, that I mean, like, because in the old days, you could have kind of like an old turntable and you just drop paint on it and spin it and patterns happen. Have you seen one of those things? You know what they're like? And it's, it is true that some of the patterns that you end up with are beautiful, right? But I don't think it's ever true that they're expressive.
Yes, that is very
And that's what I see happening with AI.
Yep.
That expression has got to do with intent, right? And that there is something that's interfering with the line of intent.
Yes, and I think that it's possible, even if you don't have direct control over the visual, so long as it is capturing the intent, that is enough for it to be expressive. And this is something that I would be interested in exploring further in future research.
You think, okay. So we will agree to disagree. Yeah, okay. But then what about, one of the things you didn't talk about at all, and I do actually think you contribute to, is, so what are the differences between templates and sketching and coding without computational support? Is that sketching is not dynamic, like that you don't have interactive capabilities with it. It may be more expressive and all of, but a template can be dynamic, that you can have interactive, and of course coding is, the hallmark of being dynamic. But you didn't talk to us about whether or not your sketching are like post-sketching result dynamic, like whether you could come and provide interactive explorations for them.
So I'm not sure I'm exactly following what you're asking here, but when you're talking about this idea of making them dynamic, so one of the interesting differences between, and this is something I was trying to capture in my framing, the difference between physical sketching versus digital sketching. Both of them are sketching, both of them are that direct manipulation. The difference is that when you do something on paper, it's kind of static and it's stuck there. Whereas if you do something digital, you can still manipulate it, but you're having to do that manually, like you're having to manually move the points around. I think what you're talking about in terms of dynamic takes it a step farther, where we're actually able to use systems to procedurally generate something. Am I kind of getting at what you're meaning by dynamic here, or is there something else that we're talking about?
Well, you actually even brought up transmog as a thing that you might try and apply, right? So transmog is taking somebody else's system and adding dynamics, right? So that's like it already exists, somebody already made it. It may be, if it's digital, then you can apply transmog to it, right?
Yep.
It's like so I think yeah, and I think there is a scale in here. So that's kind of like taking it all the way to one end. You can do some really radical things just because it happens to be digital. But and that's actually also looking at the resulting digital image as a unity, right? Now, the freeform dynamics that you get from coding is that all of the things within it, you have those kinds of options. And I think that there is something to be explored here. And I think that, like, if you think, why would you want to do this? Why would you want to actually bring these things together? The ability to be expressive and the fact that the end result is digital. And I think supporting dynamics is one of the biggest things that you get. And I think that you probably have dynamics in both of your systems, but I think it's well worth exploring.
Yep. So, I mean, what you're talking about here kind of resonates with what I call the power of mapping. So like with some of the systems that I created, don't think I actually added a slide, but there was the one in Data Garden where I had this ant visualization where each line was a different day, and then I had my activity data create as ants there. It has that kind of personal individual expressiveness through this like kind of cartooning style that I create that I really like. But then through this, I think this is, you know, what you're talking about, dynamics, through this ability to just punch it into the system, I could get the full year of my data laid out as this little army of ants. And there was something about that that like really resonated with me. And this is something that you can't get with these hand-drawn tools. You can't just take this thing, this expressive thing that you've done, and then, you know, like explode it out there.
Yeah, I think there would be something, even just like you're saying right now, to point out the dynamics that already exist in what you've done.
Interesting.
One more thing along this, or maybe two more things along this sort of line of lists of things that I compare these is the scalability.
Yep.
I'm not so sure. Where I was quite sure that you have dynamics, I am not so sure that you really have scalability.
It's an interesting question. So there's a couple of aspects to scalability. The first is the technical aspect of what the system can actually handle. And in the way that I've created, like this is just like a technical problem that needs to be solved and like how many points you can work with. But then there's the interaction question, which I think is much, much harder to solve. This, how do I control it? So like in both time splines and Data Garden, when I wanted to do these extremely like large visualizations, like the ant visualization, or some of the freeform participants ran into this where they had like 10,000 points that they wanted to work with. When you add in all of these points, it starts to become like uncontrollable. Like it's hard enough to even read it, let alone manipulate it in a way that, you know, expresses something that's important to the data. So interaction wise, I think they are somewhat limited. And of course, I wasn't able to really explore that because I ran into the technical limitations of, as soon as you added that many points, the system started to become unresponsive. So I would be interested in looking at, you know, if you can get the system to be responsive enough, do the manipulations that the system still offers, can those still be expressive in these, you know, larger data sets?
Yeah, because I mean, that's one of the things that, I mean, I'm sure people have challenged you about that at conferences and things, is, you know, that all very well, personal visualization is all, you know, expressive visualization, all very nice and everything, but you're just working with baby data sets. You're not actually working with real data, you know. I mean, yeah, okay. And I don't know quite what the format here is. I'm kind of thinking, do we get more than one round of questioning? Is it going to come back to me, or do we just?
That's what I forgot to say. So yes, we get 2 rounds.
Okay.
So we try to stay within 10 minutes per person, and then we do another round for more questions.
Okay, so then I will pass on.
Okay. Thanks. So Daniel, it's your turn.
Great, thank you. And thanks for clarifying that format. I was just about to ask that question. But you gave me just enough time to organize my thoughts. And so now I can nicely have 2 rounds. Anna, congratulations. That was, I think it's an awesome dissertation to begin with, and great presentation. It was a whirlwind of ideas. And the reason why I needed these 10 minutes was because there was so much exciting, fast-paced information coming at me that I had to take a moment to organize my thoughts and notes. I have lots of comments and discussion points and things. Let me start with one that's sort of about how you position the work. And I guess it draws a bit on some of what Sheila was just talking about. But you know, the whole thesis is designed around the idea of personal data visualization. And I wonder if you thought of an alternative framing around, say, custom data visualization. I just been sort of reflecting on that as you've been talking. I think there's like some subtle differences there that could be quite interesting to explore.
Yep.
And well, maybe I'll leave it there and see what you have to say in response.
Yes, actually, that's not something I have considered up to now. The approach that I was taking was really focusing on the personal data visualization, as we were discussing with Sheila, this idea of expressivity. But in a lot of these custom visualizations, it's not, it has to do with the context of the visualization. It's not necessarily something that somebody's designing for themselves. So like with these visualization designers, they'll be commissioned by like a company or a newspaper or something like that to create these visualizations. So it's not just about them capturing what they personally, as I'll say as an artist, want to express, but they also need to reflect kind of the goals and desires of the person that they've been commissioned for. So yes, my work, I definitely haven't really explored this direction, but there could be some interesting work to do in there on how you take in the needs of multiple stakeholders in this creative iteration process.
I think, good. Let me riff on that just a little bit, if you don't mind. So I think it ties very closely to expressivity. Well, two thoughts. One is, one reason custom may not be, I don't know, come to the forefront as an idea is probably because like we typically don't like that for some reason in our field. We want things that generalize. But I think that tools that generalize to create custom visualizations could actually be a really wonderful thing. And I think that in a lot of your work, what's special is that you're kind of pushing against what we typically value in the field in terms of like perceptual accuracy, expressivity, and personalization over perceptual accuracy, things like this. But anyway, I think this idea of like personal versus custom to me is very interesting, and I think it ties into the point of expressivity. And I'll draw like a parallel in my own career working on sketch-based user interfaces, and there have been several moments where I wanted to emphasize the importance of really having control over a tool. And even in the framing and in the terms I used, I switched to saying drawing instead of sketching, with the idea that there's some added control. Unfortunately, that leads to fewer citations because people search for sketch. But I think there might be kind of a similar thing here between personal and custom, and that like when I say a custom visualization, I'm thinking it's enabling both like the person off the street who happens to have a smartwatch and wants to do some personal data visualization, but then it's also enabling the like high-end medical illustrator or the person who's a digital artist and has like super skills. And that there's an ability to really like customize with a visual aesthetic that is perhaps informed by art and design theory, rather than like our usual approach of, perceptual science, say. And so there's somebody really bringing some real skill, but it's to create a custom visualization. And so, yeah, I wonder how you react to that, because I think it does tie into like the kinds of things Sheila was talking about in terms of expressivity.
Yep. I mean, my initial reaction to this divide between personal and custom is that custom is basically the impersonal version of personal visualization. When you're talking about custom, you kind of get into this more, the idea that there's some objective goal that we're trying to get. It takes away that kind of, it takes away the focus on the people who are creating the visualizations or the people that the visualizations are being created for, and focuses more on some kind of abstract or objective goal that we're trying to achieve with the visualization, which of course that does have that generalizability advantage because, you know, in theory, multiple people can have the same goal. Whereas when you're focusing on personal is by definition idiosyncratic, unique to the individual. The people that we're working with really matter. And I think like both perspectives can definitely have value. So like the person who their job is to design a visualization for like, you know, 100 different people who are using a smartwatch, the custom perspective might be a better way to do it because then you can abstract to the goals that the people have when they're creating with. Whereas if you were to take a personal perspective on this design thing, then you need to start thinking a little bit more about, you know, almost the emotional connection that people are working with here. Like, what is it that they're trying to achieve? I think there could be, yeah, I think there's a lot more to discussion to have around these two things, because I think the discussion might start to get into almost research perspectives, like the first person versus empirical type of research. So yeah, I think it would be. I'm not being hugely articulate on this. But I think
no, it's okay. You're not contrary to popular belief. It's not expected that you're hugely articulate in a thesis defense. The pressure is on.
Yeah.
But no, let me. Here's maybe another way of asking it. Also, is like,
Mhm.
who are the users of who are the intended users of
Yeah.
your tools? Who are the people doing the sketching?
Mhm. So in my work specifically, I've been thinking about the users in terms of individuals who are interested in working with data in this more personal way. When you're dealing with this idea of custom applications, you're almost automatically taking the perspective of the designer, the person who is thinking about the people who are going to be creating this visualization. But it's doing it from kind of like more of a step back, thinking about like their goals as opposed to, I guess it's, you're not taking emotional goals into account when you're doing that, or you're not taking the person's own desire to express things. And this is something that like I've run into a couple of times where people have asked me, so like, who wants to do this? And the answer is not necessarily everyone. So not everybody is interested in expressing things through data. So for the people that I'm working with, it is very much people who are interested in taking control over the representation and giving their own personal spin on it. Whereas when we're dealing with custom visualizations, that underlying assumption isn't necessarily there.
Yeah, I guess I hear what you're saying, that it's not necessarily there. I think in my experience working with artists who want to visualize climate data, for example, the thing is that there's necessarily a lot of emotion involved, and there's narrative and metaphor and all the things that I think are like key aesthetic qualities of the personal visualizations. But it's not really like personal data, if you know what I mean. And so I think there's something here that I'm probing on this, because like I think the research community, we need to this is useful to sort of like, you know, debate and try to organize around like, well, what is like the thing that what is the theme that we rally behind here? Because there's some elements of personal, but like, what if you're not working with personal data? There's an aesthetic commonality. There's, you know.
Interesting slide, or a slide that I ended up removing was looking at the definitions of personal visualization versus what I'm talking about in terms of expressive personal visualization.
Yeah.
So the previous work has defined personal visualization as visualization within personal contexts. Whereas when I'm talking about expressive personal visualization, we're not necessarily dealing, so like the previous definition is also specifically mentioning that we're not necessarily dealing with personal data here. When
Mhm.
I'm talking about expressive personal visualization, the personal context is still important, but it's not necessarily implicit. On expressive personal visualization, it has these attributes of personal visual style. Like you could be creating, just another bar chart, but if you're hand drawing those lines, then you could create a visual that you're very proud of, even though it has no connection to any kind of personal context, but it's still very personal. It has that, individual connection to it. And generally speaking, I don't think there's a lot of, so like when you're dealing with these like climate data, like this is something that you care about and you want to put something of yourself into solving this problem. So even if you're dealing with something where the data itself isn't personal or connected to a personal context, just by creating something that is visually compelling in your style, that I think could potentially satisfy that goal, if you would.
Mhm. Well, and I think you have the right high level approach to like the thing that enables that
Mhm.
is the expressivity of the tool. So one more sort of question in this line of thinking, and it's going to come to the AI. And let's see. So there's a couple things like I picked up on that you said. You said like one role of that is to help people produce styles that they don't have the skills to reproduce.
Mhm.
Um, and I think that's interesting. That also comes back to like who are your users? Because what if they do have the skills?
Yep.
Um, and then you also said I can't get the control that I want.
Mhm.
And of course Sheila picked up on that, so I won't go more with. But I think like that's really a critical thing, and uh, I'm just like we published a paper recently that I felt almost was like a culmination of a lot of the 3D sketch-based work we've been doing
Mhm.
for designing visualizations over the years, and um, that stuff, dates back 20, 25 years, something like that, to my dissertation time. And and I think throughout those like 2 decades, now I'm feeling really old. The 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 key is always like, man, how do you get the control and the expressivity into the tool?
Yep.
And then balance that with the data. I mean, that's what I love about your dissertation, that it's really hitting that theme. I think it's just awesome. But I will say, I think in this like recent paper, it was it was exciting, but it was also kind of like a letdown from that standpoint, because the approach we took was basically to have artists use physical materials,
Mhm.
like give up on the computer in some sense,
Yeah.
go back to the studio and use pen and ink and clay and just like digitize those things and then come up with the system to sort of do the mapping to data and so forth. But like the work that was produced that way is so visually stunning,
Mhm.
compared to a lot of the stuff that we did with sketching. And like I say, it was a little bit of like a letdown, like, oh, I guess, would have been better if we just got rid of the computers from to begin with. Of course, that's being a
Yeah,
little
yeah,
facetious,
yeah.
right? And mapping this onto, supercomputer simulations and stuff. So like there's things that obviously you can do by hand.
Yep.
But I think like a big, big thing for me was like there like to give people access to the tools that they can control
Mhm.
seemed to be a really critical step forward, and then to adapt the computer to be able to work with what these skilled visual folks can actually do.
What you
Um,
did, right, through analog methods.
yeah. And so I
Mhm.
wonder, like, as you seem to be talking about the same themes. How do I get the control that I want?
Yep.
How do you produce these styles?
Yep.
And yeah, and I guess I don't know where the question is. I think it's basically
If I
like,
can just
what do you
jump in
think
on
of
that.
what do you think of
So,
the expressivity of your
mhm.
tool relative to something like using traditional media.
Yep. So that's actually one of the big things that I was working with, especially in like the data garden work, where we're focusing a lot on this workflow stuff. So like what I'm looking for, and like just like at the start of the PhD, when I started with time splines, I'm one of those people who just collects a lot of data. So like, I've literally got hours logs for every hour that I've worked since I started my PhD. And I really wanted to create a visualization of that for now, but I ran out of time. But when I would get to try to visualize this data, it's like I would try to use these tools and I would just get stuck. And it's like, I would like something that I can just, directly say, just give me a line like this and put the data on the line. And the analog tools let you do that. Like you can take a pen and you can just make the line. But then if I were to use the analog tools, I could make the line, but then I would get stuck because then I've got all these data points and it's like, I have no control over these data points. There is too many of them. So it's, when you're talking about control, there's like two kinds of control we're dealing with here. It's that kind of expressive control where we can just do what it is we want, expressing intent for the data. But then there is the technical, the mapping control, where we can apply what it is we want to a very large set of things. So like there's these two kinds of control, and that's what like the work that I'm doing is really trying to get both of them. It's the, like, I mentioned in the start of the presentation, it's that getting the power of that mapping and the iteration and combining it with that power of the sketching where you can just get the thing you want.
Yes, it's a beautiful tension. Okay, let me pass it on. Not sure how long that was, but I feel like it was 10 minutes, which probably means it was.
Okay, next we have Samuel Durand.
Okay. Well, first, thanks for your lively and quite visual talk and presentation. I really enjoyed this. It's really cool. And thanks for your thesis also. I learned some interesting aspects and it makes me think for a lot of different aspects. I have a lot of different questions and notes, and I think I will follow up on the ones that I've started because it's one of the one I was wondering mostly about this templating question. In data garden, you are templating, like using templates.
Yeah.
I think in data garden I don't know how to say that. So you have this templating workflow, right, where people can declare what stroke mean what from the data perspective, right? And if I look at from an input visualization perspective, to me, that was the first time I see a system where you can declare the type of input data and the way to input data. This is the first system that I see doing that, kind of. And there is a lot of input visualization where you cannot input data, but it's defined before, and the input mechanism is not like dynamic in a way, right? And here it's explicit. So I was wondering what templating is in data garden. Is it defining the input mechanism? Is it formalizing the visual mapping of the visualization? Or is it even like defining a medium? And if I'm doing a template, can I give this template to someone else to like remake another visualization based on my template? Yeah, so this is it's not one question, but it's like
Yeah.
two questions
So,
in one. But
I mean, as you say that, I immediately see that there's a lot more work that can be done with Data Garden in these directions. So when we were doing Data Garden, it was really like, it was focused around this idea of capturing sketching as data. So being able to specify what the data is that we're working with here. Now, your idea of being able to take that and use it to represent different data is actually super interesting. We didn't really design it for that, but of course you could go into the definition, just change all the, words there, and then, you would get a different data set template, which you could then punch in there. So the templating process, it's really, I would kind of define it as this ability to capture these expressive strokes. So, I was talking earlier about this ant visualization that I created. The expressivity is really in that my ability to like draw these like unique little icons that I've created, and then specify how they're supposed to be laid out. So the template is really like how we structure those expressive strokes to be able to then tie them to data. It also is, so like as the authors were talking about, or like, so sorry, the expert participants were talking about, it's allowing you visually, so like through these direct manipulation methods, to also think through the data structure. So as you're, creating these, you create a thing and you think, okay, I want this data on here. And then you go to create the dimension and it's like, okay, now I have to think through like, what do these values actually mean? And it's working back and forth. It's like the lazy data binding workflow where you're working between the mapping and the visuals, but here we're working between the mapping and the visuals in a different way where we're changing the data by doing that. And it's not even so much changing the data as figuring out what the structure of the data that we're working with is. I found this personally very useful because, of course, when I'm working with my personal data, it's in like 16 different formats. And it's like, by being able to manipulate the visuals and the templated or the templated data structure, I'm able to like work through all of that, finicky structuring stuff. And then I've got this, template there that's telling me, okay, this is the format that you then need your data in. So there's another step there that we didn't even get into, which is how you can then get from that to the structure that the data is actually in. But that went way beyond the data garden scope.
So I had a follow-up question on that. It's like, how can you imagine applying this, I think this templating workflow in other application? I think it's really a beautiful workflow. I think it's have like something really, really powerful in it that could be used in like so many different visualization applications. So do you see any way that could be used?
That require me digging into other visualization applications more detailedly, but I would love to have something like that in like, Tableau where, it's generated a visualization. And it's like, can I just, say, see all these marks here? I'd like them to be like this. And then I would like them to, kind of increase like this. So like, that ability to just go in there and, move things around to be the way I want and have it interpret what it is that I'm doing in terms of the structure. Of course, that's where it gets bloody complicated, that, interpretation of the structure that I'm working with. And again, that's why in Data Garden, we limited it to one kind of structure. This is something else that actually I didn't mention, but because Data Garden is focused on these hierarchical structures, it's actually quite difficult to expand from that. We had one participant, so like in the reproduction study, we were working with novice participants, and I found this like super interesting. The participant, as they were drawing their hierarchy, was adding labels to the graph. Because like it was clearly just like how they thought about it. It's like, okay, so this branch is going to be Monday, so they added the M. The problem they ran into was the system was aggressively trying to interpret all of those annotations as part of the hierarchy, and it totally threw the system off. Like the hierarchy was completely messed up. And so it's like, I would love to have this feature in, these other these other systems where I can just directly add the visuals that I want and then explain to the system what it is that it's supposed to mean. But also that is bloody difficult to do and cover like anything like a large range of structures. So yes, there's definitely more work that can be done there too.
Super cool. I was wondering about a word. I think at the beginning of your thesis you are mentioning several times visualization structure. And like two words, but it's like the term that you are using often and often and often. And I'm myself, I'm using sometimes like visual structure as word to explain relation between different visual cue, but I don't have a really good definition. So I was wondering what was your idea of behind visualization structure? What does that mean? Is it like the visual mapping? Is it idiom? Is it like a set of cue? Is it, or what does that mean? Like maybe there is no definition. I don't know. It's really an open
Mhm.
question, but
Visualization structure, it's interesting actually to discuss it in terms of data garden with this implicit and explicit structure. So like visualization structure, if I was to give a definition off the top of my head, it's how the placement and the relationship between the visual elements communicates data. So, that includes both the attributes of the visual elements as well as their spatial relations to each other, as well as, and like if you want to get, more abstract, how the overall layout itself can communicate information. So like there's all of these like different levels to the structure, but then structures also have these implicit characteristics, which is what we ran into in Data Garden, where we just implemented a super simple algorithm that takes the explicit structure and uses that to generate a visualization, but completely ignores all these implicit structural elements. And that, yes, it fails to capture the actual structure that we're talking about. So yeah, I would describe it as like the relations between the elements and as a additional separate thing, how those relations communicate data.
okay. Well, maybe I'm gonna use this definition later. um, I had another question. It's like wait a second. I think there is I don't know if you didn't show this figure in your slides, so I don't know if it's really important, but there is this figure, like figure 22, it's page 68, that I really liked in your thesis. It's basically 3 points, data mapping,
Yes.
visual design. There is different arrow in between each of them. And you are like separating what is pre-existing, what is author, and what is the result.
Yep.
And I was wondering, because I was looking at it and it's made me think a lot. And I was wondering, you have these arrows that are bent. And I was wondering what this bending was meaning, because it's like different relation between, like, it's basically also different where tools can provide things, right? Or you can like create a visualization or create data with a visual tool, right? So I was wondering if you can explain is that part, because I find it interesting.
Yes. So I apologize to everybody who has not seen this graph, because this is probably going to make
Yeah,
no
I'm
sense
sorry.
to you. So the reason that those arrows are bent is because the way I was trying to describe the visualization workflows, it's not like you go from, I'm trying to remember what I had in that graph. It was data, mapping, and visual elements, I think.
Yeah, data mapping and visual design.
Yeah. So some workflows are very prescribed, where you have to go from data to mapping to visual elements, whereas some workflows are a lot more iterative. So I believe I have one where the arrows kind of go like this, and I think it's the lazy data binding workflow, where it's data mapping or data visuals to mapping. So the bending in the arrows is really expressing that kind of non-rigidity of the different workflows and how we work with them. So when we're working with lazy data binding, you have this back and forth between the mapping and visuals, where you're kind of like merging the two together in a more, what do you want to call that, flexible way.
That's very cool. Okay, thank you very much. I have a lot of other questions, but I think I already missed the that's fine.
Okay, next
Okay, good. So I have the hard task of following up of all of these questions. So I'm going to I guess extend a little bit one of these prior questions that hinted at what I wanted to ask but didn't quite get there. And that is the application use case. So I think Dan asked you about what the intended users, and you said, well, people who are interested in doing something with data. Yeah. So to me, in the end, the way you wrote in your thesis, it seems like mostly for personal reminiscence.
Yep.
But is that all?
So when I'm thinking through, like, so when I'm designing these applications, I'm really thinking through what is it that I want to be able to achieve with these applications. But as we point out within the larger papers, they of course have applications beyond this. The sketch-based templating workflow could just as easily be used by a visualization designer who's been commissioned by, I don't know, the health board to create something that will appeal to children. So, you know, this ability to work with the data to manipulate it, where they have to create a visualization, they're handed like a set of data in who knows what format, and they have to think through, okay, what is it that I'm trying to visualize? How am I going to make that visually appealing? What is like the data of this that I'm going to work with? It could just as easily be used within these applications. So while my thesis really targets this kind of personal aspect, the applications themselves definitely have a wider effect.
But I mean, even specifically, let's take time spines, for example.
Yes.
Let's take that specifically. Do you think that could be used other than for this purpose of me reflecting on my own data?
So I was actually really happy to see. So when I went to present time splines, I went and attended a whole bunch of the other storytelling visualization systems. And one of the presentations, they were working with timelines of women convicts in I believe it was from like records from like English history. And what they'd done is they'd visualized them, and it was these idiosyncratic timelines. And I'm like, oh my gosh, somebody's actually using these. So they had these lines that were like doing portraits of the women, and they were adding like the events that they collected from these data sets. So this is another, you know, potential applications of time splines. If you were, you know, iterating on what that design might look like, you can use the custom shape of the timeline to illustrate or to outline the portrait that you're going for, see how the different shapes in the line will affect the data and stuff like that. And in this case, it was to draw attention to the women that were exported from, I believe it was England to Australia during this time period. So yeah, I've actually seen applications where time splines would be useful.
Yeah, the one I was wondering about is whether it could be useful in situations where you have people who need to retell an event, or a significant portion of their life, or could be people who just witnessed something, or in therapy or something where people, because memory isn't necessarily linear either, right? But I think it will be really interesting to think about situations like this, because it also ties in with this question of who are the end users, right? So you had this user study, that's my next question, where you took, I think, 12 people and they recreated the visualization.
Yes, we gave them the example visualizations and instructions for how to create.
And then you had another one where you took, I'm saying experts, right? So researchers and designers, and they actually created their own thing. Why didn't the 12 other people create their own thing?
Mostly for time constraint reasons. We wanted to try and get this down within a 1 hour period. So the designers were given 3 hours on their own time in order to create this visualization. And we specifically got expert researchers because we wanted to get at what kind of the, we were using this, sorry, let me pull these words from 2 years ago. We were using this framework of wide walls, high ceiling, low threshold to do the evaluation. So the low threshold, we just wanted to understand whether or not the concepts within the application would make enough sense to people for them to be able to create a visualization that they already had a good idea of what they wanted to do with. The experts, we were looking at more that high ceiling. So like with somebody who knows the potential range of expressivity that you can get with visualization, what are they able to achieve? So yeah, it would be really cool to find out with novice users what they would be able to achieve with the system. But I suspect it would take them even longer than the expert users, because they not only need to learn the system, but they also need to kind of explore the potential of data visualization as they're less familiar with it. So it would be really interesting to run a follow-up study with novice users, but I think it would have to be a different structure than what we had.
Yeah, and I think that ties in exactly to my last question, where I think here with these kinds of systems, you're running into this problem where you're working in an environment where typically learning is sort of taken as a given, right? If you want to be a good sketcher, you'll sketch and you'll sketch and you'll sketch even more. And at some time in the future, it will start looking the way you want it to look.
Yeah.
You can do simple stuff, no problem, right?
Mhm.
Star people or whatever. But if you really want to, be what you said before, like get the thing on paper that you have in your head, it will take training.
Yep.
From these digital tools, we typically expect as little learning as possible, right? That's one of these goals. Make them walk up and use, make them immediately usable. Do you think with the types of things that you're aiming at, this should still be a goal? Should this still be a goal for this kind of software, or should we let go of that? And it's important for evaluation purposes.
Yes. So the systems that I was creating, I was very much creating them as this kind of walk up and use system. So this it's kind of like this ability to kind of explore the potential of these visualizations. What ideally, if somebody was using it for a longer period of time, the value that I can see in the systems that I created are people are able to learn how to work with data, the possibilities of how they can express data, how they can add their own personal spin on it. Of course, the systems that I've created are not expert systems. You're not going to get good at, creating clean and readable visualizations with what I've made. So yeah, so the idea that, I mean, here's the thing. With the non-expert users, it was actually super interesting to see like the different types of non-expert users that we were working with. The people who actually had the easiest time with working with the data garden application were people who already had this concept of instrumentation. Like one of the people who finished really quickly was somebody who had animation experience. So somebody who already had this idea of like how you can control visuals using some other kind of structure. So when it comes up to when it comes to this walk up and learning thing, there's always something that you're going to have to be learning. Like you're going to have to understand, like to get your mind around this concept of visually representing data. So some things, it's better to have them walk up and learn. You don't want to have to learn how to be a perfect artist at the same time as you're trying to learn how to get your mind around data. And we were really focusing more on the get your mind around data as opposed to the art. So the amount of time you invest in this means that you're going to get better at doing this kind of thing. And we wanted to make something that was really quick to get people into the idea that it might be worth investing time in this. Hopefully that answers the question in a kind of rambly roundabout way.
I'll pass on.
Okay, so my turn.
Yeah.
I'd like to follow up on that actually.
Mhm.
From what I understood of Data Garden, you actually are aiming rather to support the creation of visualizations that have a hierarchical structure, because you have this notion of branches, and then you have leaves, and you can have attributes on these leaves and so on. And so it seems like it's a pretty statically defined structure in the sense that you have one level of branch and then you have the leaves. Okay. Is that correct?
Sort of. It's an infinite hierarchy.
It's infinite.
Yes,
Okay.
you can have as many levels of hierarchy as you want
So you
until
could have
start
multiple
running into problems
branches, so
with
you
the
can branch out from.
Yes.
Okay. Still, so in several of the examples that you showed and that are in the dissertation as well, we see examples that are not obviously hierarchical. Like there's, well, you could argue that it is a bit hierarchical, but like there's this shelf with books and so on. So, it's not immediately apparent that this is a tree. Okay.
Yep.
And I was wondering if participants to the study actually struggled with that, or did they want to create visualizations in which this hierarchical aspect was not necessarily, an important element, and did they still manage to create what they wanted without, keeping this walk up and use philosophy?
There it is. Yes. So one of the reasons that we one of the advantages of doing the freeform study with experts is that they're the ones who will really push the system to its limits. So we actually had somebody who was like, well, hey, can I use this hierarchical structure to create a scatter plot? And the answer is yes. It does take a little bit of hammer work to make it work, but it's interesting, like the range that people can get out of these these hierarchical visualizations. So sorry, can you give me the question?
So the question was, how difficult was it for people, both like expert designers and more lay users, to actually fit the models that you have with this hierarchical structure?
Generally, it was fairly easy. Of course, we did get the more lower levels of hierarchies in this. So yeah, like with the books, we're actually looking at, so the visualization, the axes are kind of going off of a central axis here,
Yeah.
so you can't actually see the axis. But yeah, so we're seeing people using like 2 to 3 levels of hierarchy. So there were some interesting things people were doing with that. And again, here we have like a primary axis, sub-axes, things on the sub-axes, and then subnotes on those things. So generally people were actually getting pretty creative with what you could do with these hierarchies. But yeah, the fact that it has to be a hierarchy is somewhat limiting in the system. But in order to do this kind of automated interpretation, to get that kind of sketch workflow where it's just walk up and use, you really do have to limit, or at least we did, have to limit the structure that you're trying to interpret.
Yeah, for sure. So I guess my question was more like, did they struggle? You know, like did they have to make an effort, a mental effort to actually fit this hierarchical structure, like to do the shelf, the bookshelf?
Unfortunately, I cannot give you a very detailed answer to that because this particular study was run in Toronto by Fanny.
Okay.
Hi, Fanny. Thank you. So yes, maybe we can have a group discussion about that sometime later.
Okay, and one other quick question, and then we'll do the second phase, and I won't talk anymore at that point, is more about time spines. So I was wondering, all the examples you showed, it looks like there was a single main track that could have an arbitrary trajectory. And I was kind of, in my mind, drawing a parallel with storylines, which is quite different, obviously, but that raised the question of whether you support multiple tracks.
Yes.
In
So
there, and did people make use of that?
Yes. Let me see if I can just quickly find adaptation. Yep. So it's this section here. Come back. There we go. So yes, time splines, this is what I was talking about in terms of that limitation in the storytelling section. Time splines only supports single lines that are distinct from each other. So this is a visualization, sorry about the resolution, but this is a visualization I did of my academic career, where I started with my industry time and then my master's. And then here I have the line split. And this is something that I can do in the system because you can have as many timelines as you would like, but there's no real connection between them. So I had to do this manually where I'm linking the two together. So while it does have that flexibility that you can do this, it doesn't add that mapping support. So like if I wanted to change my visual representation here, I could change that, but then I'd have to manually move the line.
You have the notion of branch.
Yes. So it has that flexibility, but lacks that mapping support.
Okay, thanks. So we'll go for a second round. If jury members have additional questions, we'll try to keep it again within 5-10 minutes max per person. So Sheila.
Yes, I have to unmute myself. Right. Actually, another protocol question first. Anna, have you seen the reports or do you see them after this?
Oh, I see them. Yeah, I got to read them before the.
Because then I can do with a little bit less explanation. So this notion that I brought up in my report about that one of the things that we need to do is understand a space by providing good point solutions within the space. And I think that if we define the space as, different kinds of ways of integrating personal sketching abilities, personal sketching ideas, power, skills, etc., and machine contributions, right? So in your talk to us today, you really kind of focused, and I think you have quite a few more that you mentioned in your actual thesis, though I would have to go back and look for them. But how populated is this space right now that's in this balance between personal sketching and machine support?
So what you're kind of referencing there is how I define expressive personal visualization. To clarify a little bit, when you're talking about personal sketching, the sketching aspect gives you a few different attributes that make a visualization personal, like that personal visual style. There was another attribute that didn't make it into the presentation at all that I call choice of visual aesthetic. So that attribute is how the choice of like the visuals that you're using, like vector graphics or a kind of more sketchy style, how that itself can communicate information. So like the, if I'm understanding you correctly, you're asking about how we can better integrate these different attributes that we can get from sketching with this power for doing the mapping. Is that correct?
Maybe. I'm just kind of actually asking you more to speculate what would be a completely different point in this space.
That is extremely difficult to do. So what we're talking, so like when I was trying to, like for the thesis, when I'm trying to define this space that I was working with, I was really trying to get at, okay, so what exactly makes these personal visualizations expressive and personal? And so that's how I define this dimension of these expressive personal visualizations. The mapping I really consider to be kind of a different space or a different a dimension almost that I didn't really get into. And I think there's something to it there that's linked to this notion of scalability that you're talking about. So yeah, like when we're dealing with these personal spaces, you can have a very wide variety or a very large range of different scales of data that you're working with from, you know, I really want to dig down on these 5 events from my life and explore how they are in relation to each other, to I have 100,000 data points from my automatic heart rate tracker, and I want to explore how these are in relation to my overall life. So when we're talking about this mapping, I think there's another dimension that could be pulled out here in another direction. In the personal dimension, these were kind of what do you call them? Steps, something. The points that I pulled out on this dimension of, or this attribute of what makes something personal, these were the ones that I found were really relevant to the work that I had done, the things that I was really aiming to support. But of course, it's not a complete list. I suspect that you could probably do more work there in defining like this dimension of what makes something personal.
Okay. But and the mapping you see as another dimension?
I see it as a separate dimension, yes.
Do you see any other dimensions that you could say, well, we could think about these other dimensions?
So
like, for instance, Samuel's dimension of input.
Yes. So the I didn't really look at the creation as a separate dimension, but I could see that being important. So when I'm talking about this idea of story kernels, where we suddenly have to take the context of how people are making and sharing these visualization, how they are using these as story kernels, I think that could, exploring that area would really bring a need for this kind of, yeah, this input dimension, what tools people are using for creating visualizations. I think it would also bring a need for a sharing dimension. So like, what are the you know, steps in terms of how people want to share, what kind of control they want to maintain over this kind of sharing. In the thesis itself, I also have the dimension that I didn't even get into of the form of the visualization, where I'm talking about 2D versus 3D, dynamic versus static. And there was another one that I cannot for the moment remember because it didn't make it into the presentation. So yes, there are a lot of different things that we could explore. And I think the I think there's an infinite number of dimensions, and which dimensions we pull out will be very much based on the context in which we are, the context that we're looking to explore.
You think there are an infinite number of dimensions, so we'll never actually manage to explore this space as a community?
Well, we'll never manage to completely explore it. Dimensions are a way of framing things that help us think. There are an infinite number of ways to think about things. Not all of them are useful.
Could you specify a non-useful one?
Not off the top of my head, but I'll get back to you on that.
Okay. So I don't know. In fact, okay, maybe here is even another dimension. So Petra brought up like, why do we want this personalization? Why do we want to support this? Like what do we gain from this? Is it just somebody, is it really just memorabilia? And why does that matter to people, and why are we so interested in this? Have you ever thought about looking at what people do in context of this type of gathering their own data and personal visualization, and what people do in art therapy?
No, I have not had a chance to look at this, but I suspect, especially if I was going to be able, or if I had an opportunity to dig further into this idea of story kernels, I think that's something I would very much be looking into, is how people use data in conjunction with storytelling to help do this like self-reflection, this sense-making type of activity. So art therapy would definitely be somewhere that would be interesting to explore. I think also, you know, so the, what do you call that? Quantified self movement would be another context that would be worth looking into. These people, you know, like me, who are weirdos and like to collect data on themselves and like to explore that data, that this context of why they do that in there.
Have you ever speculated, even for yourself, as you say you like to collect data, about what's behind that, like what's behind that compulsion? Like if you look at quantified self, this is not the rare person. This is lots of people.
Yep. So an interesting thing, I'm not sure if this made it into the thesis, but it was an idea that I was working with. There's this parallel that you can draw between storytelling and data visualization, where both of them are just, you know, ways of putting order into chaos. So like one of the things that I'm constantly collecting is my mood data. As I mentioned, when I get tense, my mood starts going all over the place and it starts interfering with my work. And I would like it to stop doing that. And there doesn't seem to be a way to do that, but by collecting this data, at the very least, I can, you know, put some order into it. I can start looking at patterns. I can at least feel that even if I can't control it, I know what's going on. So it's this kind of, for me, it's very much this sense making, this way of finding things I can control in an essentially uncontrollable world.
Right. I mean, so there's, like you said, so we have a little bit of examples, though actually not very many people actually taking it on seriously. And I guess that's part of the reason why we keep coming back to Dear Data, because we have a whole year of people actually really looking at their own data.
Seriously doing it.
But in the real world, like if you look at quantified self, and if you look at scrapbooking, for instance, like there are people all over the world who do scrapbooking and baby books, and so this compulsion to actually have, collect, preserve our own data is pretty widespread in humanity, right? And so you just stated yourself, and if you actually think back to what you just said to me about your moods, what do you get out of doing this? What's the benefit for you in collecting and maybe making some kind of annotations about your visualization about your moods? You actually said it. I'm just asking you to say it out loud again with more consciousness.
So there are actually two sides to this. There is the easy to articulate side, which I think is the one that tends to land in research, is the one where there's some practical use. For example, in the visualization I have here, you can't see it, but there's this little section on the end here where I have this is number of hours I was working versus how my mood was doing. There's a section where I have like extreme hours worked followed by a crash in mood. So it's stuff like that where it's like, yeah, okay, I now have some, you know, not very rigorous, but statistical evidence that working too much is not good for my mood levels. So like there's these easy to articulate goals and benefits that you get, but the harder to articulate benefit, which is the one that like you it's the one that's really connected to this personal style thing, is just that, creative urge that we have to make something and have that something be something that I made. And that's the one that's really hard to articulate and that I'd really like to be able to pin down somehow. It's
Okay.
where I was talking about this research I'd like to do to be able to express this properly.
Right. Okay. So there you've actually said two things. And one
Mhm.
is the benefits for yourself in actually self-management, having your life go more the way you want it to.
Mhm.
But the other, you were actually talking about like an artistic benefit and a benefit of feeling like I did that there, I created something, right?
Yeah. Mhm.
Do you think there are any others? So there's
Um,
two. There's two, and they're both actually pretty powerful
Mhm.
benefits.
So these are the two that I can pull from my own personal experience. But of course, I haven't done like a, broad study of this.
No, I'm not asking for that. Just
Yeah, no, what I was going to say on that, so when I started the PhD, and again, something that didn't make it into the presentation, I did this preliminary study. And one of the things I was exploring was, why might people actually want to do this? And I got a few different options, and a lot of them landed in that, easier to articulate area where people were talking about, I'd like to be healthier, or I'd like to, be more organized. So these kind of, collecting data to understand my patterns so that I can lead a, better life for whatever, benefit it was that they were looking for. Then there were the other ones that fall more into that like expressive category, where people were interested in kind of more these reflection things, this just, capturing something. And so I would be interested in doing a more rigorous study along those lines. So like I said, I haven't had a chance to do this yet, but just kind of exploring the space of, why people want to do these things. And I expect like 80% you'll end up with the easy to articulate answer, but it's like, how could we get at this harder to express thing of, personal expression almost?
okay. I'm satisfied. I can pass on.
Okay, Dan, any other questions?
Okay, yeah, it comes to me. Let me take it in a different direction, because you didn't really have a chance to talk about your immersive moment system.
Yes.
But I wanted to hear a little more from you on going in that immersive direction, since I'm interested in sketching and immersion.
Mhm.
And I think what led me to it over the years is working with spatial data.
Mhm.
But your situation isn't necessarily tied to spatial at all. So what I'm wondering is, can you talk about how these three concepts relate? I'm going to pose it as three concepts. So let's say like sketching
Mhm.
for viz authoring, okay?
Mhm.
And then immersion or presence in,
Mhm.
I'm using XR these days. I mean, it's AR, VR, MR, we'll call it XR. So, okay, so sketching, immersion and presence, and XR,
Mhm.
and then also spatial data,
Mhm.
including 3D. So, like, how do your tools kind of fit into that love triangle?
So you picked three things. I would actually shift it. So the
Okay.
tool that we're looking at building, it actually gets a lot more into the personal side of things rather than the sketching side. So as we've been talking about this idea of sketching, there's this idea of, intent and expression and just getting what it is you want out there. So that's the attribute of sketching that we're really looking at with this application. So the idea that behind it is we want to support people in being able to create their own immersive stories. So VR has this, ability to, it has this kind of like wow effect. This, I am in a different place in time. And that's kind of the effect we want people to be able to leverage in expressing their own personal stories. So this is, so to get back to this thing that I have troubles articulating, it's this, ability to have, there's this thing that you want to express the sense of being in this place and time. And that's what I would like to be able to get out there. So the way that I connect it to my work is it's actually connected to these attributes of personal visualization, these attributes of personal context, these attributes of personal style. The data portion to it is kind of like a side thing. I realized that like I can include this data that I collect, this stuff that, you know, I have it all and there's stuff that I want to say about it. I can bring it into this immersive context and get that kind of, that thing I want to express, this kind of sense of this is, you know, me almost. So yeah, it's the way I approach it sounds very different from the way you're asking me to approach it. So can you give me the question again and maybe I can see how it fits together?
All right, let's riff on this. So I think the when you describe the wow effect, I think what you're describing is the notion of presence.
Yes,
And
I think
that's
so.
well defined in the VR research community and well studied. So I think you're mostly talking about, yes, this the illusion of presence in an alternative reality.
Mm.
And it sounds like you're saying that what you're most interested in is exploring that aspect from the standpoint of personal data.
Can I jump in on that?
Yeah.
It's not even personal data so much as the personal expression. So like
Okay.
there's this thing you can do with VR, and I'd like to be able to make it so that you can do that without needing to be a programmer.
Yeah. Yeah. Right. And I think that's where the sketching comes in, that you can
Yes.
do that without needing to be a programmer.
Mm-hmm. And
Yeah.
the data kind of, it's part of that in that I like to express myself through data. I like to have these, you know, things that I've pinned down, like, you know, my mood tracking or my hours tracking, and then be able to bring those into these spaces as part of that expression.
Yeah. Okay. So I think coming back to my question, I was kind of identifying three things, and I think you're starting to get around how these relate. So
Yeah.
there's sort of the wow effect is the presence,
Mm-hmm.
right? There's a particular like affordance for, you know, expression that can enable. The problem is that you know, to do that, you've got to be like graduate level graphics programmer. Until relatively recently anyway. And so like, so you're creating the authoring tool
Mm-hmm.
that allows people to use that without programming.
Yep.
And I think like the last piece that I'm interested in is just the role of different types of data in that environment. So like
Yes.
I've gone to the immersive environments not just because of the presence, but also because of the spatial perception for looking at, you know, complex spatial relationships.
Mm-hmm.
And actually, to be honest, over the years in the data viz community, moving to 3D for any other reason has really been frowned upon. And so that's, I guess, in part why I'm kind of pushing on this. So you're using this medium for the presence,
Yes.
for the presence aspect, and not necessarily for the spatial reasoning aspect, as I
Yes.
understand. And so I guess that's part of what I'm wondering if you
Well,
I don't
can
know.
say
Would you agree? Is
that
that your is that your approach?
that is what we
And
want
what do
to
you think the
do. This
promise of it
is
is?
very much work in progress. So we'll see
Mhm.
if we can, you know, get it off the ground and get people behind it, at least enough to, you know, get it out there. So yeah, it's actually kind of interesting as you're talking about that spatial data. So like one of the things that we're getting, so the application that I'm working with is called Moments. This idea that I was talking about in time splines with the ability to link together different parts of the thing. One of the things that we're including within the Moments application is this ability. So like the thing is like separated into scenes. And when you're talking about different kinds of data, it's actually that's another part to it where you're able to bring in like 2D media as well as 3D media, and by extension also abstract data. And then you can link those things together through what we call teleporters. And I'll be interested to see, again, the work's still very much in progress, but I'll be interested to see what kind of data structures this creates through these connections and contextualized connections between these different scenes. So, when you're talking about this 3D spatialized data, we're creating an interesting new, data structure through doing this. And I'll be interested to see what direction that goes in.
Mm-hmm. Okay, interesting. I think there's a lot more to discuss here on the data that I'll skip over, but I'll just put like a hint out that I think like even in the videos you showed of your tools where you have sort of the go-between in terms of like a data table on one side and the visualization in progress on the other, like that's super compelling to me. And I think to imagine how that might work with the different types of data, for example, data that are not in a tabular format, would be really, really interesting to do.
Very much so.
Let me ask one little, I put a timer on this time because I'm like, I'm not going over. So I have 1 more minute and 10 seconds. And I wanted to ask one more thing about terminology.
Okay.
And use the phrase kernel storytelling, I think,
Yes.
to explain one of the coolest new ideas, I think. And tell me, like, why did you pick that phrase? What is that kernel storytelling?
Oh, I didn't pick that. I found it.
Oh, okay. Well, tell me. Yeah.
Yes. So this is kernel storytelling is actually a concept that came up in I think it's like verbal communication. So it's this group of researchers who were looking at how people do verbal storytelling. And this was one of the things that they found was this idea of kernel storytelling. So it comes up in conversation where you have people like, in a normal conversation, and they'll drop these kernels. So it's like, you'll mention, oh yes, that's like so-and-so. And the reason they're calling it kernel storytelling is you drop the kernel and then it can grow to a different size depending on the context. So, somebody else might respond with, oh yes, tell me more, or, that's like this, and like taking it in a different direction. So it's this kind of storytelling that is very, very contextual. It has to do with who you're talking to, the direction that they take it in. So this is something that I find very interesting in terms of data visualization. It's kind of this taking visualization out of this context of being, a unit unto itself, and then putting it in this context where it might only be part of another storytelling, I don't know, practice almost. So yes, I didn't come up with that is the answer to that question.
Okay, interesting. Thank you. All right, well, let me pass it on to the next person. Samuel?
Yeah, okay. I'm gonna be quick, but can you come back to the video of the time spline demo?
Yes, I can, in theory. Time splines, spirals, time splines. There you go. So, is this the one you were talking about? Oops, sorry.
Yes.
I apologize. My thing is not cooperating with me.
No problem. It's when the person is making the loop, Yeah, this is this one. So it's really funny. So it's quite I think it's quite humoristic video through a visualization. So the person starts a job, then he quits the job, and what he writes, it's between you have the depression. Right?
Yeah.
And this is that he can identify that basically his running habits are going really, really down while he's walking. I like this video a lot because it's well, it's quite fun and sad. But so it's a way to picture this functionality that you have in TimeSlang, which is like an annotation. And I think you are speaking quite a lot about that in your thesis, that there is a blurry line between what an annotation is and what data is in the context of personal visualization. And here it's funny because it seems that the most important part uh, of the visualization is not inside the data, which is basically the information that between these 2 points, the person and the depression. And I was wondering, from your perspective right now, uh, with your experience on personal visualization, what do you consider data, or what is your definition of data for in your context? How do you see that?
Yeah, so this is actually something that I personally really like, messing with. So data, when we're talking about data, very often we're meaning abstract, categorical, and the continuous data. Whereas when I'm talking about data, like the kind of stuff that I'm tracking about myself, some of it, yes, does fall into that category, like, my hours, I'm giving it an actual number that I worked. But then the mood tracking data, it's kind of a different thing. And it's actually kind of hard to capture that. Like what I'm trying to quantify almost is this very nebulous thing. And this sort of, it's so what I would really like to get at here is this definition almost of what kind of information we value. So other information that I have is my photo gallery. And there's a ton of information here, but it's not really quantifiable information. And so what one of the things that I really like about time splines is how it gives you this ability to capture and pin down and express things about unquantifiable information. So like, this depression line here, like, it's a simple black scribble, but it is very expressive. So it's this kind of unquantifiable information. And Data Garden is actually really interesting because it doesn't really capture that unquantifiable information as data. Like the data that it captures is only quantifiable information. But one of the things it let me do was create that mood garden. And that, I think, like that flower visualization really kind of gets at some of this unquantifiable information, like that's how I think and feel about my mood data. So when you're asking me what my definition of data is, when I talk about data, for the most part, I'm talking about that, analytic definition, that continuous or categorical information. But when I'm talking about expressivity, that is also a kind of data. It's information that is trying to be captured. So yes, long and complicated answer to that question, but it's something that I really like thinking about.
Yeah, sorry, I'm good. In Data Garden, basically so in this tool, actually, it's already the case. Like now there is like a line, like depression become a part of the data set, right?
Mhm.
And it seems like for me, what is interesting here is like there is a mix of a lot of data sources. Also. Like so, the depression come from maybe the author. So it's like but in certain tool, we will say, oh, yeah, no, this is not a data point. It's an annotation. It's something on top of the visualization. But here you like clearly assume that it should be a data point, or it seems to be a data point. And yeah, I was wondering if you consider also this maybe this notion of different sources or yeah, I don't know.
Yes, previous research on work called data hunches is actually really interesting from this perspective. They were looking at, so like there's the data, which is collected in a certain way and presumably trying to be as unbiased and scientific as possible. But then there's these data hunches, like often very extremely important information. Like, for example, this entire chunk of the data, it's completely worthless because the machine broke down. So like there's this other source of information. And I can't remember if this made it into the thesis, but one of the things I was talking about in this blurring the line between annotation and data, it really only happens when the original data set is coming from a similar source as the annotation. So this is, of course, one of the examples here. where the information that's been collected here, and like I have similar kinds of data sets. I mean, this is fictional, I just made it up. I have similar kinds of data sets where I'm collecting event data. So when I am collecting event data, a lot of that is coming from me reading through like emails and looking at, you know, location data and remembering things and then capturing those things. And then the annotations are coming from a similar place where it's like I'm looking at the information and then I'm remembering more things, and those are things that I want to capture. So like this point of depression here, this is coming from a very similar source as, you know, the rest of the data, like these events here that were just added in. It's remembering what was happening at that time and capturing that as information.
Sure. Thank you. Well, I have a last question, maybe.
Yeah.
So because this personal visualization and this timeline are made kind of for either reflecting or thinking, or maybe having it around, like displaying, not only for communicating. I was wondering, do you think, and all of most of the examples that you are providing are examples that are temporal in a way, and so I was of past events. So I was wondering, do you think doing such a thing could manipulate or change my memory in any way? I'm saying that because there is a lot of studies that have been done on how we can manipulate memory by yeah. So okay.
Yep. So that's not something I have personally gotten into. It's a very interesting question. Another interesting question are, in what context does that matter? In terms of sense making, when you're remembering things, you're just trying to get a handle on things, and you may remember them differently depending on the tools that you have to help you do that. So I haven't personally studied it, but yeah, like this kernel storytelling thing, to go back to that again, that's something else that might be worth considering within that context is, you know, why are we doing this? And does that manipulation matter? And personally, I think it's almost impossible not to manipulate your memories as you try to remember them. So yes, yeah, I mean, sorry, can I like add one other thing to that? This is actually just occurred to me. This is another reason why I really like doing this kind of mood tracking thing, because it gives me a totally different perspective on my memories. The way I think about events that happened in the past when I'm looking at data is totally different depending on the kind of data that I'm looking at. And this kind of statistical mood data gives me a different perspective that I really like having.
Thank you very much.
Okay, I'll really only ask one question. And you've been asked many conceptual questions, and I hear you're very strong technically, so I'll ask you a technical. I feel like I'm obliged to ask you a technical question. So one of the things where computer systems are nice compared to hand-drawn sketches is that you can do animation, right? And since we're all about time, we can represent time differently. How hard would it be to extend what you've implemented to include, one is animation, mapping data to moving leaves or whatever, is this in the sketch base, how hard is it technically? Second is, how about dynamically changing data?
So I haven't worked a lot with dynamically changing data. Could you give me an example of that?
So let's say one leaf or whatever it is represents your heart rate, and you want to show how did your heart rate fluctuate over a range of time that you're representing with that leaf.
Yeah. So from a practical perspective, I could tell you if I was going to try and take on a challenge like that, I would basically go back to scratch and work on it from there. These systems that I'm working with, data structures that are underlying them, do not have any sense of dynamics, that kind of connection that you would need for that kind of animation built in. So while you could make something that on the surface would look very similar, under the hood, it would probably be extremely different. So I would say that it would probably be extremely difficult to add that sort of thing in, but I couldn't say for sure until I'd actually dug into the kind of data that we want to work with. animation, expressive animation is something that I'd be very interested to see. Like even just like, you know, could you make a glyph that is actually a combination of 3 glyphs and, you know, dynamically changes between those? Could that be used as another channel to represent things? So yeah, definitely an interesting question and not one I could answer off the top of my head. Oops. It's fine.
Okay. Okay,
I'm done.
thanks. So to finish this session, we'll have the 2 advisors, starting maybe with Fanny, who is remote. Say a few words or ask questions or whatever you want to do.
Whatever I want. Yeah. Can you hear me well?
Uh-oh.
Hello.
Yeah. Fanny, go
Okay.
ahead.
Yeah. Well, thank you very much, everybody, for great discussion, and Anna for answering all of these conceptual and more technical questions. I will try to be quick in the sake of time. First, I would like to thank you, Anna, for a wonderful journey together. It was really, really a great ride working on this doctoral research with you. I feel lucky that you were part of like the University of Toronto, even though you were hosted there, so visiting us every summer. It was great 3 months that the whole lab, I can tell, was looking forward to every year for you to come back. A great sunshine in the lab. In terms of the work, I want to thank you for like, you know, having trusted Fannis and I. So we had a bit of a difficult start where we had to take time to align ourselves. And I think looking back, we achieved a great relationship in that you have trusted us on some of the things that, you know, we're not necessarily putting you in the most comfortable situation and thing. And I believe if you were to draw your timeline, maybe at the beginning, there could be like some wiggle and things in your timeline visualization, but eventually, like it paid off, and it was really wonderful that that you trusted some of our steering and input. And at the same time, something that I really appreciate in you is that you've never compromised on yourself and whatever was important for you. And you've challenged, I guess, me at times. I was like not necessarily convinced at some of the ideas that you might push for and things, but you kept defending them and you took ownership and you directed that. So I find we achieved a great a great kind of like, you know, let's work together to take the best of everybody's ideas and things. So I really appreciated that. I'm very, very sad that I cannot be on site today. I really would have loved to celebrate with you the end of this this great journey. You should be proud of the work you achieved. You've been a true rocket, like through the 3 years. You put some ideas like, you know, come to life, and that was really, really wonderful to see. And you've grown a bunch during the thesis, so I feel you're a very strong researcher right now. I just want to ask like one quick question. So looking at your timeline, maybe it's bumpy, maybe it's weird, like the one during the thesis journey, right? If you could time travel and talk to your 3-year younger self as we started this thesis, what do you think you would do differently to make it easier, better, or what do you think you might have missed out on this journey and you would do differently, or what do you love you did the way you did and you would keep no change?
So I wouldn't really change anything simply because it's, you know, it's kind of funny. If you were to ask me the question, what would you tell your 3 years ago self? The thing I would probably be telling my 3 years ago self is, no, you've pretty much got the right idea. It's going to be extremely bumpy at times, and you just have to stick through it, and it will work out somehow, some way. But yes, I think that's the reality of doing a PhD. So for a few of those of you who are considering going into a PhD, that's just how it works. You get into a PhD and you kind of figure out how it's going to work. And hopefully, if everything works out, you're going to get some great research out of it. And you will certainly learn a heck of a lot. So, yeah.
Well, thank you, Anna. It's only like, you know, until the next time that we can celebrate in person together.
Yes,
but yeah.
Well, I will be coming to visit Toronto mostly to collect some things that I left with my friends who have kindly been holding on to them for me. So I will let you know.
And until then, yeah, I will pass it on to Fanis.
Okay, so it's my time. So yeah. So first to say, yeah, congratulations for, I mean, it's wonderful work, right? I'm very also proud of the results that we, what you produced. Actually, I feel I would like to repeat also to say that we're very lucky to have you. I don't know, I think that was a ex-PhD student who was the team at the UBC at the time who spread. We had this PhD position and we're very lucky to have you here from outside, you know, without expecting that. Right? So it was also, yes, as so I would like also to mention that you, yes, you are one of the most talented people that I have worked with, right? I can, I can say that. The other thing is because, yeah, Fanny said that there was these moments at the beginning, and I would say, yeah, for people who probably don't have enough context, so you see these visualizations, these timelines, sometimes plans, these, right? It's actually, it reflects perfectly, you know, the kind of mood of of Anna. So if you're looking for animations, right, this kind of, it could be, you know, this is an example of animated kind of entity, right, of data. Right? You can see the flower that goes, opens and then closes.
Actually, just to jump on that, somebody suggested it'd be really interesting if you could get like multiple versions of time splines and see the animation between it. Because like, as I said, I would really have liked to be able to complete that that timeline at the end there with like all the information I've collected down to the end of the PhD. And I'd probably visualize that starting period different now than I did all the way back then. So, you know, animating between those two things would also be, I'd call it highly expressive.
So, yeah, my question will be perhaps two parts. The first one is that you said that you have data from all throughout your thesis. Right? Yep. And you said that you didn't have time to show them. So the question is first, there's one first question. First question is this the real reason, or is this probably the reason that you didn't want to embarrass your advisor?
No, this is definitely the real reason. So the process of going through this data, it's something that I need to have a period of time where I'm not feeling pressured to just sit down and reflect on the data and how I want to visualize it, to work with it, to explore it. And yeah, unfortunately, the last 3 weeks have been from one thing to another thing to another thing to another thing, and I just haven't had that space of time that I need to sit down and really work through it.
Okay, but so, you have an idea how you will visualize this?
I have an idea, and I expect it to 100% change as I work with the data, which is the beautiful thing about time splines. It's designed to let you do that.
But I don't know if you can explain the idea that you have.
Yeah, so I had a partial visualization. You saw it actually. It was in the actually you saw it too. It was in the midterm report. So I'd probably start with something like that, something that's, you know, fairly compacted to kind of get it all into one screen. But then I would like to like explore the different periods of time. So like, yeah, that beginning period when things were kind of like all over the place. I want to get that expressivity in there. So I'd want to be adding these different like custom shapes to different periods, and you know, the sections where things were just going ding, because I could spend all my time programming, like get that kind of expressivity in there. And that just, it takes time, it takes reflection, and yeah.
If so, you have an example, right, for the kind of shape that you would
yes. Yeah, yeah.
Okay, I will. So let's wait for these
final
visualizations.
Yeah, yeah, yeah. So yeah. And question 2?
No, that's I mean, the first one, yes, tell us what was the reason, and the second, you know, but, because I'm curious about where I'm going to be with Fanny.
Okay, so is there anybody with a PhD in the room who would like to ask a question? That's the last format that we have.
Uh-oh. I noticed that I've got 3 colleagues here who all have PhDs now.
Now the building will close at some point, so be careful. Oh, okay, so the jury members are going to stay in this room and we call you back when we have made a decision and returned the post.
So before you go, I'd actually like
Yeah.
to get this hooked up again so that I can, you guys are all getting moved off the stream, but I'd like to still be able to get on the stream and have a chat with the folks who have been patiently
Just
watching
make
along.
sure that your mic is off.
Yes, that
What-
things are set
Yeah.
up so that you can communicate.
Yeah, right.
I'm going to
So what we should do is you.
Wait, no, no, you're not going anywhere.
Jury members. And then I'd like to get this one in the main room.
Okay.
Should we stay here, Emmanuel?
So you guys are all going to be shuffled into a Zoom room.
A
along
new
with
Zoom room,
Catherine's
yeah, because
computer,
this one
which
is.
connected to the room.
Okay, so you're putting them elsewhere?
No, you
No.
guys are all going. So this computer, which is connected to the room,
Yeah.
is going into a Zoom room, and this is. the
Ah,
one
yeah,
that's
okay,
in the
okay.
same-
We're going to a breakout. Yeah, we got the invitation for a breakout.